Good morning, everyone. So today we are going into 3.3 part 1. Okay, so today we're talking about function notation. Okay, function notation is a way to write functions using, I'm going to say f of x. Okay, and I'll explain to you what that means here over here in notes. Oh, we are on page 71 here in your student journal. So function notation is a special way to write these functions. We've been talking about functions, how they're different from just a relation. We can write functions in a specific way using function notation. Okay, and I want us to pay super close attention right now because this f of x thing confuses people a lot. Okay, and I think it's because they just aren't quite sure what it means. So let's say we had an equation, a simple little equation. Let's call it y equals 2x plus 1. Okay, let's think about that for a second. Is this a function? Yes, this is a function. Okay, it's a linear function because we don't have any exponents. X and y are separate terms. Okay, we know this is a linear function. So if we know something is a function, I can write it two ways. So we have this way right here with this equation, this y equals something. We're used to seeing that. Or we can write it in function notation. So we have this f parentheses x. Okay, we say this f of x. Okay, when you see that f parentheses x thing, you say that f of x, and then all this other stuff is exactly the same, 2x plus 1. Okay, and people get all confused. The second they do great, and then the second they see that f of x, they think I'm multiplying f and x. They think that f is a variable. They get very tripped up by this. Okay, it's not saying f times x. It's saying this function, which we're going to call f, and it doesn't always have to be f. A lot of times you'll see g of x or h of x. It can be any variable, okay, or any letter, I should say. It's not really a variable, okay? It's saying this function f, when I plug in x, is what it means. And if this function notation really throws you off, it really breaks your brain, whenever you see that f of x, you could swap it out for y. Okay? Because that's what f of x means. It means this is the output when I plug in x. Okay, but the reason we use function notation is it's a lot more useful because we can say, okay, the reason that we use this is we can say, okay, let's take that function f. Okay, I know my function f is this 2x plus 1 when we plug in x. But now I can say, okay, well, that's nice, but let's plug in 3. Okay, so instead of my input being x, now my input is 3. Or I could say f of 5 or f of 27. That means take this equation or this function, 2x plus 1, and plug in 3 or 5 or 27 in for x. All right, so we, instead of writing 2x plus 1 now, would write 2 times 3 plus 1, and then we'd solve it out. We'd keep this f of 3, and again, this is where people get tripped up. They say, oh, let's move this 3 to the other side, okay? That's not what it's saying. It's saying, let's find out the value when we plug 3 into this function f. So we're not going to do anything with this f or this 3. We're only worried about that side of our function. Okay, so 2 times 3 is 6 plus 1. That's a goofy looking 1. And then we can simplify again. F of 3 is 7. Okay, if we wanted to be really fancy, we could say, I know this is my X, that's my input. I know this is my Y, this is my output. So I could even say, as a coordinate, okay, when I plug in 3, I get 7, okay? F of 3 is 7. When I plug 3 into that function, I get 7. All right, and another thing that I could tell you is instead of saying, all right, what happens when I plug in 3? I could say, let's make sure I give you a number that looks nice. I could say f of x is equal to 11. Okay, instead of giving you a number to plug in for x, I could say, here's what f of x is equal to. What is x? What's the value of x that makes this f of x, that makes this output, that makes y equal to 11? Okay, so instead of plugging in 11 for x, you're going to say, okay, this 2x plus 1, I don't know what x is, but I know that it's going to equal 11. Okay, instead of f of x here, I'm going to say, well, let's make that equal to 11. Right, and now this is just a two-step equation I can solve out. So I can subtract a 1, subtract a 1, so I get 10 is equal to 2x, and then divide it out here. So divide by 2, divide by 2, and I end up with 5 is equal to x. Okay, so when f of x is 11, x is 5. Okay, 5, 11 is a solution to that function. Okay, again, if this trips you up, sometimes when you just see that f of x, if you want to think, okay, y is equal to 11, instead of y equals 2x plus 1, 11 equals 2x plus 1. For some people, it's helpful to think of f of x like y because that's what it kind of means, right? Now let's see if I can find a couple quick examples for us. Okay, so it says, for these, evaluate the function when x is equal to all these different numbers. So let's just do -4 for 1. I just want to show you a quick example. So when I'm plugging in -4, I'm going to say instead of f of x isn't my input anymore. Now my input is -4. Okay, is equal to negative, and I'm plugging in -4 for x, plus 4. Okay, again, don't do anything with this f of -4. It's not really part of your equation. It's not really part of your math. It's just saying when I plug in -4 in for my input. Okay, -4 is +4, so 4 plus 4 is going to be equal to 8. All right, so f of -4 is equal to 8. You could always just write your final answer like that. All right. Then here's another example, kind of like the second thing I showed you. We've got r of x is equal to 4x minus 3, and r of x is equal to 33. So I'm not plugging in 33 as my input value. I'm saying, look, r of x is equal to 33. Okay, so instead of r of x, I'm going to say 33 is equal to 4x minus 3. Okay, I'm going to add 3 to both sides. This is just a two-step equation now. So 36 equals 4x. Divide by 4, and I get 9 is equal to x. Okay, so when you get something like this where it says r of x is equal to 33, that's when you know, okay, I'm not plugging this in for x. I'm plugging it in for this and trying to find what x is. Okay, not tomorrow, you have a weekend. So on Monday, we're going to get into how to match up these functions with graphs. But for now, you're just worrying about making sure you understand function notation, plugging in numbers, and then also trying to find what the input is when you're given the output. Okay, this stuff isn't easy. So if you have any questions, email me, hop on that Google Meet today at 1. All right, and I hope you have a great rest of your day and have a great weekend.